Welcome to day 10 of 16 Algebra 2 Honors Summer School classes. This lecture notes is about exponential growth and decay. I have a summary page here with some notes on exponential growth and decay. You should read this carefully and try the problems on the page. Actually, the homework today is from this same thing. An exponential function is of the form y is equal to a times b to the x, or the function of x is equal to a times b to the x, where a is the y-intercept, and b is going to be the base of the exponent. If it's greater than 1, you have growth. If it's between 0 and 1, you have decay. And that's the long and short of it. So on our problems today, we start with this first problem. We're supposed to tell if it's growth or decay and then sketch it. And since this is between 0 and 1, that means that it's decay. And then we look at this other value 2, which is the y-intercept, where it's going to cross the y. Because when x is 0, this is 2. And it's going to be decayed, so it's going to go down like this. The second problem, we have 4 as our base of our exponent, and that means it's greater than 1, so it's going to be growth. And the second value, this a value is going to be 0.5, so at 0, a is where it intersects the y-axis, and this would be growth. Here we have to rewrite the function to determine whether it's exponential growth or decay, and find the percent rate of change. Well, I could write this as 6 times, and then we have a constant, which is 0.082 to the negative 0.25, times 0.082 to the t. And if I can simplify this, I get raised to the 4th decimal. This is my constant, and that's going to be times 1 minus 0.18 to the t. So it's going to be between 0 and 1, which means that it's decay, and it's going to be 18%, or 0.18, which is a negative. It's a decreasing, so it's decay. In this problem, we start off, I can simplify this once again, just like I did before. I have a constant of 1.12 to the 0.3 power, and I multiply that times 1.12 to the t power. Here we have this constant is approximately 9.3112 when it's to the 4th decimal place. And that's a constant. And I'm going to multiply that times 1.12 to the t power. And you can see that this is going to be more than, this thing in parentheses is more than 1, so it's going to be growth. And the growth is going to be 12%. Last of all, we have the Menendez family bought a new house 10 years ago for $120,000. It's now worth $191,000. Assuming a steady growth rate, what is the yearly rate of appreciation? So we're looking for the yearly rate of growth, meaning it's going to be compounded yearly. My n value is 1. So I have $191,000 is what it was, is today, and 120,000 is what it was before, and the growth rate is 1 plus some rate to the 10 years. And I could have put this to 191,000, 121,000, but I'm going to divide it anyway, so it's going to give me the same value if I divided it with 191,000, 120,000, or 191 and 120. So I'll get this decimal point, 1.5917 to 4th decimal point, and that's equal to my exponent here. To solve this, I'm just going to take the 10th root of both sides. When I take the 10th root of this, I get 1.0476 to the 4th decimal is equal to 1 plus r. So I subtract 1 from both sides and I get r is equal to 0.0476 or about 4.8%. And that checks with what I did the previous day. Right here is what I did before. Very good. That's all I have to share for today. If you have any questions, give me a call or email, but I'll be available. Thanks.